Okay, today we are going to be covering lesson 11.8, finding the volume of rectangular prisms. Our essential question today is how can you find the volume of a rectangular prism? Really today what we're going to start trying to do is moving away from this idea of counting blocks and start using the formula that we talked about last time. Remember, the formula for finding volume is going to be length times width times height. And just like we talked about last week, this length times width part, that is what we often refer to as the base area of our rectangular prism. So we're going to do a few problems today. We're going to talk about a couple of key things to look out for, and that should be it. So it says here that Sid built the rectangular prism shown using 1-inch cubes. The prism has a base that is a rectangle that is a height of 4 cubes. What is the volume of the rectangular prism that Sid built? So we have a base for our rectangle. The height is 4 cubes. So what we need to figure out is what is the area of our base. So if we look here across the front of our prism, we see that this is 4 units across, and we see that it is 3 units deep. So the area of our base is going to be 4 times 3, which gives us 12 square inches. Now we take that base area of 12 and we're going to multiply it by our height. Our height, remember, as they told us in our problem, was 4 cubes. So we get 12 times 4. They've demonstrated this over here because we can see that we have our first layer is 12, our second layer is 12, our third layer is 12, and our fourth layer is 12. So every time we add another layer to this rectangular prism, we add another 12 unit cubes, right? So we get 12 plus 12 plus 12 plus 12, which, as you know, repeated addition is the same as multiplication, right? So that's why we're going to multiply the area of that base times the height of our prism. To finish this one off, 4 times 12 is 48. And now the key here is we have to make sure we use the right units. So here we see that it's 1-inch cubes. So we are working with inches. And because they're cubes, they are cubic inches. Taking a look at another one here, it says that Tony stacks cube-shaped beads that measure 1 centimeter on each side. On each edge in a storage box, the box can hold 6 layers of 24 cubes with no gaps or overlaps. What is the volume of her storage box? So here they tell us that each layer is 24, right? So this being a 6 by 4 means that this layer is 24 cubes and 24 cubes and so on and so forth, right? So every layer here gives us 24 more cubes. So since each layer is 24 cubes and there are 6 layers, we get 24 times 6, right? Our base includes 24 cubes, right? Our layer, we have 6 layers, 24 times 6. So 6 times 4 is 24. 6 times 2 is 12. Plus 2 is also 12. And so we have 124 cubes. We take a look here. We know that each one is a measure of 1 centimeter. So they are unit cubes and they are cubic centimeters. Now, one thing that we need to kind of like differentiate on is the base area versus the fact that we're saying that this is a layer of 24 cubic units. Remember, area is a two-dimensional shape, right? So when we look at area, we are talking about just length and width. So this doesn't really get any volume until we add some height. Now, when we add one layer, right, then we are giving it some height, but that height is just 1 unit. And so when we multiply length times width, that gives us our area, right? So in this case, our area is 24 centimeters square, right? And they don't become cubic until we give it this bit of height, right? Like that is what is required for this to get its third dimension. But the good thing is we all know that if we multiply anything by 1, we really don't change the number. The only thing that changes here is instead of it being centimeters squared, when we multiply that by 1 centimeter, right, then we get centimeters cubed. So let's take a second to talk about like what that means. Remember when we talked about exponents with tens, right? We said that 10 times 10 times 10 could be written as 10 to the power of 3. 10 is our base, right? That's our repeated factor. And then the 3 is how many times that 10 is repeated, right? So we have that 10 repeated once, twice, and a third time. We can do the same thing with variables, right? So if we wanted to put like a into a problem, we could do it with a. We can also do it when we're working with like units, right? So for example, when we're working with centimeters, if we have centimeters times centimeters times centimeters, right? Then we can kind of think of this in the same way that we thought of this problem up here. Here we had 10 was our repeated factor. Down on the bottom here, centimeter is our repeated factor, so it ends up being our base. And then we just look at how many times does that centimeter show up. Well, it shows up once, twice, and 3 times. So that's why it's cubic centimeters, right? So if we think about length, right, then this is just centimeters, right? We'll say it's 1 centimeter. So that ends up being this one, 1 centimeter. We add our width, right? Also 1 centimeter ends up showing up here in our problem, right? And so that's why area is not centimeters cubed, but instead, because we just have 1 and 2 centimeters, it would be centimeters squared. When we add our third dimension, right, we add our height to our box, right? This is also 1 centimeter. So we multiplied 1 centimeter times 1 centimeter times 1 centimeter. Well, 1 times 1 times 1 is 1. And then because we have centimeters times centimeters times centimeters, right? We went from this two-dimensional shape that was area to our third dimension, which is volume, giving us cubic centimeters. So hopefully that makes a little bit of sense. So let's look at another problem here, and let's apply that same idea. If we take a look at this one, right, we want to find the volume of our rectangular prism. So we're going to start off by looking at our formula. Remember, volume is length times width times height. Our length is 4 inches. Our width is 5 inches, which means that the area of the base of this rectangular prism is 4 times 5. Well, 4 times 5 is 20. They're inches. Remember, area is square units, right? Because we multiplied inches by inches. So we get a base area of 20 square inches. We could see this if we just looked at the top of our rectangular prism, right? Because it's going to be an exact image of mirror image of the bottom, right? And if we just look at the top, right, those are our 20 square inches. Now, the third step in this process is that after we find our base area by multiplying length times width, we're going to multiply it by the height, right? So 4 times 5 was 20. We're going to multiply that by our height of 6 inches. So our height is 6 inches. We've already got 20 square inches. 6 times 0 is 0, and 6 times 2 is 12. Remember, we've now multiplied inches times inches times inches. So we've done it 3 times, giving us our third dimension of cubic inches. So the answer here is 100 cubic inches. Now, when we are working on volume, one thing that is really important is that we make sure we are using all of the right numbers, right? Because these are really simple. They have just labeled the length, the width, and the height. But sometimes you'll get like crazier shapes, or they'll go and they'll start like labeling everything, right? This is also 4 units, and this is 4 units, and this is 5 units, and 5 units, and this is 6 units, and this is also 6 units, right? And so all of a sudden we look at this and we have all of these numbers, and we have to make sure that we are picking the right 3 numbers to multiply by. So the key here is that we always want to make sure that we get all 3 dimensions of our shape, right? We want to get this length. We want to make sure that we get this length. And we want to make sure that we get this length, right? We want to make sure that we're getting all 3 of those dimensions so that we can find an accurate volume for our rectangular prism. Okay, so we're going to take a look at a couple together. Pause the video, try to solve it, and then come back and let's see how you did. Okay, so I'm going to look at this one, and I am going to find that my length and my width, right? So length times width is 5 times 6, and that gives me my base area of 30 square feet, right? I am finding volume though, not just area. So I need to multiply this times the height. See, so I've already done that unit. I've done that unit. I need to do this one over here. So 5 times 30, 5 times 0 is 0, 5 times 3 is 15. So it's 150 cubic feet. All right, looking at another one here. Again, pause it, try to solve it, and come on back. So volume is length times width times height. My length and my width, my base is 7 times 7, which gives me 49. So that's the area of my base. And now I multiply that by my height. Well, I've already done this length, and I've done this length. So now I need to get this one here, which is multiplying that by 4. 4 times 9 is 36. And 4 times 4 is 16 plus 3, which is 19. So this one has a volume of 196 cubic inches. All right, we're going to take a look at one other problem today. And this one relates back to the problem that we did earlier, where we looked at this one, right? So relating the height to volume about Tony's stacked cubes. Remember that here we found that our volume was 124 cubic centimeters. Each of these cubes had a side length of 1 centimeter, giving it a volume of 1 cubic centimeter. So the question down here is, what if each cube shape bead measured 2 centimeters on each edge? Right, so instead of it being a 1 by 1 by 1, it's a 2 by 2 by 2, right? Like, what would happen to our volume here? It's still centimeters, right? So the unit size didn't change, but each of the beads doubled in length, width, and height. So how would the volume change, right? It's going to be bigger, right? But like, how much bigger? Well, if we think about it, originally this was 6 centimeters across the front here. Well, now each of these side lengths is not just 1 centimeter, it's 2. So we're going to multiply that times 2, which means that the front here is twice as big. So it's 12 centimeters across. I'm going to get rid of that number so we don't get confused by it. Looking at this measurement, again, there are 4 beads stacked here, but each of them has a length of 2 centimeters, so we get 2 times 4. So again, this side is now also doubled, right? So 12 centimeters, doubled it across the front, doubled it going this way. We're going to also double the height of it. So instead of it being 6 centimeters tall, we're going to multiply that by 2, and it's going to be 12 centimeters tall. So if we double all 3 dimensions, how much bigger is our volume? I think the easiest way might actually be to write it down. So we have our length times width times height, right? So 6 times 4 times 6. Well, for each of these, we came in and we multiplied them by 2. So that's times 2, and that's times 2, and that is times 2. So if we just look at this part of it, 2 times 2 times 2, well, 2 times 2 times 2 is 8, right? So we took the volume of the original cube, or rectangular prism, sorry, and we're multiplying that by a factor of 8. So if we took each bead and we doubled the length, height, and width of each bead, we don't just double the volume, we increase it by a factor of 8, because 2 times 2 times 2, because we have to double the length, we have to double the width, and we have to double the height. So just keep that in mind. If you double every dimension, you don't just double the volume of your rectangular prism, you actually increase it by a factor of 8. All right, that is our lesson for today. If you have any questions, please let me know, and good luck.